Hello बच्चों, let's read the question. A small amount of solution containing 24 Na radionuclide with activity A is equals to 2 into 10 raised to the power 3 dps was administered into blood of a patient in hospital. After 5 hours, a sample of blood drawn out from the patient showed an activity of 16 dpm per cc. T half for 24 Na is 15 hours. Find A. Volume of blood in patient. B. Activity of blood sample drawn after a further time of 5 hours. So this is difficult level question of nuclear chemistry. Let's first understand the key concept, then the meaning of question to solve this question. So first, key concept. First key concept to solve this question is rate of disintegration is given by the formula R is equals to lambda into N. Here R is rate of disintegration and lambda is decay constant. Decay constant, which is equals to 0.693 whole divided by T half. And N is number of nuclei at time T. Now, let's understand the second formula to solve this question. Rate law expression is given by the formula T is equals to 2.303 whole divided by lambda log of N naught by N. So this is the second formula to solve this question. We know the meaning of symbols. T is time, lambda is decay constant, and N naught is number of nuclei initially, N is number of nuclei at time T. Now let's solve it further. So we have what we have given. What we have given is rate of decay of 24 Na is equals to 2 into 10 raised to the power 3 dps. Let's convert it into dpm because we have also the unit given in dpm. So to make all the unit in one form, let's convert it into dpm. So it is equals to 2 into 10 raised to the power 3 into 60 dpm. Now we have also given rate of decay of 24 Na after 5 hours. After 5 hours, which is equals to 16 dpm per cc. We can also write it as 16 dpm per ml because cc and ml are equal. Also we have given the T half for 24 Na is equals to 15 hours. So let's solve it further. We get volume of blood of patient BVml. So the rate of decay of 24 Na is equals to 2 into 60 into 10 raised to power 3 dpm injected in VmL blood of cell. In VmL blood of cell. Why VmL? Because we have assumed the blood of patient is VmL. Now, rate of decay of 24 Na after 5 hours is equals to 16 into V dpm. Why 16 into dpm? Because we have assumed as blood of patient is VmL and it is given that the rate of decay of 24 Na after 5 hours is 16 dpm per ml. So we have changed it as 16 dpm per cc, and by multiply it into V dpm we get the rate of decay. Now let's solve it further. T is given by 2.303 whole divided by lambda log of n naught by n. At the end of 5 hours, it is given by 5 is equals to 2.303 whole divided by lambda, and lambda is equals to 0.693 whole divided by t half. As we have know the formula of t half, and t half is given as 15 hours. So which is equals to 15 log of initially it is 120 into 10 raised to power 3 rate of decay whole divided by 16 into V after 5 hours. Now after solving it we get V as 5.95 into 10 raised to power 3 ml. So this is the answer of first part. Now let's solve its second part. For second part, we have to calculate the activity of blood of sample after a further time of 5 hours. So now time become 10 hours because 5 hours then 5 hours. After adding we get 10 is equals to 2.303 whole divided by same 0.693 into 15 log 120 into 10 raised to power 3 because it is initially 120 into 10 raised to power 3 upon A because we have to calculate after 10 hours. Now after calculating it we get A as 75.6 into 10 raised to power 3 dpm, but it is for VmL because we have calculated here it for VmL. Now for 1 ml what we have to do? We have to divide it by V, and the value of V is into 10 raised to power 3 dpm whole divided by V, and V is 5.95 into 10 raised to power 3 and it is for 1 ml, not for VmL, for 1 ml. After calculating it we get it as 12.71 dpm per ml. Calculate it in dpm, then we have to divide it by 60 and we get as 0.2118 dps per ml. So our answer of second part is 12.71 dpm per ml and also 0.2118 dps per ml, and the answer of first part is 5.95 into 10 to the power 3 ml. So I hope you will understand it well. Thank you and best of luck.